Alright, this is the beginning of trimester 2. What we're going to start out by doing is reviewing some of the things that we learned in trimester 1. The first thing we'll talk about is all the formulas that you have learned so far. So, one of them happens to be the slope formula, and slope is defined as m, and we'll write this as the y minus y over x minus x. It's also known as rise over run. Standard form is a special form of a linear equation. Remember, that's an equation of a line. And what it has is it has the x and the y on the left-hand side, or first, as I like to say, and then we have it equal to a c value. A, b, and c are constants, and a and b cannot both be 0. If they both equal to 0, then we just have 0 equals c, and that doesn't work out. So it's ax plus by equals c, where the x and the y are on the same side of the equation. When we're going to find the x and y intercepts from the standard form, this stands for standard form, what we're going to be doing is find the x-intercept. Remember, we keep the x portion, and we put 0 in for the y portion. Remember, the b's are constants. And to find the y-intercept, we keep the y portion and put 0 in for the x, and then we would be able to solve. We'll do that in some other examples a little bit later on in these videos. The other thing we've talked about in trimester 1 is graphing. We know 2 ways of graphing. We could graph 1 by making a t-chart, and 2 by finding the x and y intercepts. We'll review both of those in these videos as well. And then this last part is actually shouldn't be there. We're not going to review graphing given a point and the slope. We haven't actually learned that yet. We'll do that this trimester. M equals y2 minus y1 over x2 minus x1. So we're going to do x1, y1, and x2, y2. These are always ordered pairs. So that what this ends up being is I'm going to take y2, which is my negative 2 value. I'm going to place a minus sign between it because it calls for a minus, and then I'll place 3 here for my y1 value. My x2 value is 8, and I'll place a minus sign between it with my x1 value next. What this ends up giving me is negative 5. I changed my signs to plus the opposite. I should show that. A negative 5 and a positive 3. This is not going to be reduced any further. We do not make it a mixed number, so we are finished. The next example I have here, I will do it in blue so you can see the difference. I've got x1, y1, x2, y2. Again, always xy coordinates. I have my slope. My slope is equal to my y2 value, negative 5, minus my y1 value of 4, over my x2 value of negative 2, minus my x1 value of negative 3. Always minus signs between them. Change my signs to plus the opposite, and I'll come up with my answer of negative 9 over 1. That does just mean a negative 9. Y1, x2, y2. I'm going to do y2 minus y1 over x2 minus x1. Change my signs to plus the opposite, and I end up with the answer of 3 over 0. 0 on the bottom is considered undefined. 0 on the top is considered 0. So I'll write that as well. If I would have got 0 over 5, this would have been 0. 0 on bottom is undefined. 0 on top is 0. We're going to find the x-intercept. We can do that by plugging in 0 for the y portion. So we want to keep the x portion, and we want to get rid of the y portion. So we put 0 in for y. This gives me 5x. That makes that go away, and I get equals negative 4. Divide by 5 on both sides, I get x is negative 4/5. The y-intercept, I can find the y-intercept by plugging 0 in for the x portion, keeping the y portion. That gives me 0. Now I need to solve for y, so I will do that by adding 4 to both sides. and that ends up giving me a 6y divided by 6 on both sides. I could say it's 4 over 6 or reduce it to be 2/3. And I'm going to find the x and y intercepts for this. So the x-intercept, remember we keep the x portion and we put 0 in for y. What that does is it covers this up, makes it 0, and so we get x equals negative 15. The y portion, or the y-intercept, we plug 0 in for x and we keep the y portion. What that gives me is this is 0, so I'd have a negative 3y equals negative 15. Divide by negative 3 on both sides, and I get a positive 5 for my y-intercept. T-chart is really nice when you have a y equals equation, and x and y intercepts are nice when you have the ax plus by equals c equation, so the standard form. So since in this problem I have the standard form, I am going to go ahead and use x and y intercepts to graph. The x-intercept then ends up being, I'm going to keep the x portion, put 0 in for y, and those fall out. I get 4x equals 20. Divide by 4 on both sides, I get x is 5. On the x-axis, right there's the x-axis, I will plot 5. The y-intercept, I plug 0 in for the x part, and I keep the y portion. I did go ahead and change the sign to plus the opposite right there. This gives me 0, so I have negative 5y equals 20. Divide by negative 5 on both sides, and I get y is negative 4. The y-axis, I plug negative 4 there, and then I would connect my dots. On this next equation, this is a y equals equation. It will be much easier to create an xy t-chart or a t-chart xy chart rather than using x and y intercepts. You could still do x and y intercepts if that's what you want to do. I'm going to pick just negative 1, 0, and 1. What I like to do is I always say I'm going to keep everything. I'm going to replace my x with parentheses and put plus 2. So inside the parentheses first, I'm going to place a negative 1. So y equals negative 1. It would be 1 plus 2, which is 3. The next one, I'm going to keep everything except the x, put parentheses there instead, put in 0. Negative 0 is just 0. 0 plus 2 is 2. The next one I'm going to do, keep everything the same, except make the x parentheses, put plus 2. So I have negative parentheses plus 2. Inside the parentheses, put 1. Negative 1 plus 1. Oh, this is negative 1 plus 2. Sorry about that. Y equals 1. So I get 1 here. Graphing these ordered pairs, I've got negative 1, comma 3. 0 on the x, 2 on the y, and 1, 1. Connect those together, and I'm finished. Last example is quadratic. What I end up doing is I want a t-chart on this. I will place negative 2, negative 1, 0, 1, and 2, so that way I make sure and get a u. As I said, since it was a y equals equation, I was going to go ahead and use a t-chart, so I picked these values because I knew from prior experience that x squared makes a u or a hill. This one actually makes a hill because this negative out here in front. Let's show how this works. I've got y equals negative parentheses squared plus 1. This is the way I like to do it. I put negative 2 in first. I say, okay, for following order of operations, I keep my negative. Negative 2 times negative 2 is 4 plus 1. So y is negative 3. So I have one ordered pair, negative 2, negative 3. The next time I'm going to copy everything except the x, make parentheses, squared plus 1. All I'm doing is copying this negative. This is my x squared plus 1. I'm going to put negative 1 in. I end up getting negative order of operations. Negative 1 times negative 1 is 1 plus 1. Negative 1 plus 1 is 0. So I have negative 1, 0 now. The next one, I have y equals negative parentheses squared plus 1. I will put 0 in, so I have negative 0 squared plus 1. This gives me 0 plus 1, which is 1. The next one, I have y equals negative parentheses squared plus 1. I'm going to put 1 in. 1 times 1 is 1, I put my negative out front, plus 1, y equals negative 1 plus 1 is 0, so that's also another 0, and you can see it's coming back up. And the last one here, I've got y equals negative parentheses squared plus 1. Inside the parentheses, I'll put 2. Y equals 2 squared, which is 4. Bring down my negative. Negative 4 plus 1 is negative 3. So now I have 5 ordered pairs, and I'll graph each one of those. So I've got negative 2, negative 3. That's right here. Negative 1 on the x. 0, 0, 1, 1, 0, and 2, negative 3. This does make what's known as a parabola, an upside down U, and I am finished.